Hello class, welcome to the lesson of New Energy Vehicle Motor and Control System Maintenance. Today, let us continue learning about the structure of DC motors. We have already learned about the stator part of a DC motor, and today we will focus on the rotor part. The rotor consists of an armature core, armature winding, commutator, shaft and fan, etc. The rotor is the rotating part of a DC motor, also known as the armature. When used as a generator, it generates induced electromotive force through the winding for power generation. When used as a motor, it outputs electromagnetic torque through the winding to rotate the rotor. The rotor is the most important core component of a motor. 1. Armature core. It's a part of the main magnetic circuit of a DC motor and also supports the armature winding. The armature winding is embedded in the core slots. Armature winding. When the armature rotates, the direction of magnetic flux in the core constantly changes, resulting in eddy current and hysteresis losses. To reduce these losses, the armature core is generally made by stacking insulated silicon steel sheets, each being 0.5 millimeters thick. 2. Composition of the armature winding. The armature winding is composed of insulated conductors wound into coils and placed in the slots of the armature core. Each coil has two terminals connected to the corresponding commutator segments according to a certain pattern. All the coils form a closed armature winding, which is a part of the circuit and also a crucial component for energy conversion. The role of the armature winding is to generate electromagnetic torque and induced electromotive force, which is a critical component for energy conversion in DC motors. 3. Composition of the commutator. The commutator is composed of many copper segments insulated from each other by mica sheets. The commutator is a cylindrical assembly of copper segments with special shapes, and mica sheets providing insulation between them. The raised end is connected to the ends of the armature winding. The commutator's role is to convert the AC electromotive force and current in the armature into DC electromotive force and current in the brushes, while ensuring a consistent torque direction on all conductors. 4. The shaft is usually made of forged alloy steel to ensure reliable operation of the motor. The shaft's role is to transmit torque. 5. The air gap is the gap between the stator and rotor. It is a crucial parameter of the motor and is generally set between 0.5 millimeters and 2 millimeters. A too small air gap makes motor assembly difficult and enhances high-order harmonic magnetic field, resulting in additional losses, poor startup performance, and unreliable operation. Excessive air gap will cause a decrease in power factor during motor operation, resulting in degraded motor performance. That's all for today's lesson. Thanks for watching!